assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
In this problem, there's a 50-gram stone attached to the bottom of a spring that's vibrating. It has a maximum speed of 15 centimeters per second and a period of 0.5 seconds. And we're asked to find the spring constant, the amplitude, and the frequency of these oscillations. So the first thing we're going to do is find the spring constant. And we do that by using the equation omega equals the square root of k over m, of our spring constant divided by the mass. And we also are going to use omega equals 2 pi over t so that we can actually substitute this term in for our omega. So our final equation is actually going to end up being 2 pi over t equals the square root of k over m. Now we're going to need to rearrange that to solve for k. And when we do that, so we'll square everything, so we would end up with 4 pi squared over t squared equals k over m, and then multiply by both sides by m, so we end up with 4 pi squared m over t squared equals k. And now we can just substitute in our known values. So we're going to end up with 4 pi squared times our mass, which is 50 grams or 0.05 kilograms, divided by our t squared, and our period is 0.5 squared, is going to equal our k. And when we solve for k, we get that our spring constant equals 7.9 newtons per meter. The next part we're asked to find is the amplitude. And since we have the velocity, the maximum velocity, we can use velocity equals xm times omega. And again, we're going to substitute in our 2 pi over t for our omega here. So we end up with velocity equals xm times 2 pi over t. And then when we solve for xm, we will get that xm equals our period times our velocity divided by 2 pi. And now, once again, we're just going to substitute in those values. So we're going to have xm equals our period, which is 0.5 seconds, times our velocity, which is 15 centimeters per second, but we're going to convert that to meters, so 0.15 meters per second, and divide that by 2 pi. And so we get a value of xm, our amplitude, equals 0.0119 meters. Okay, and last but not least, we're asked to find the frequency, which is probably the easiest of all of these, because frequency equals 1 over our period. So we're just going to go ahead and substitute in right off the bat, because we know that our period is 0.5 seconds, which gives us a frequency of 2 hertz.